Good morning friends. Now today we are going to start with the second chapter of this book, that is chapter number 2, the polynomials. Right. Now before starting this chapter we have already discussed a brief description of this in standard 9. We have already know it, right? Let us start with the definition of the polynomials. What does a polynomial mean? Let us see what is a polynomial. That a polynomial basically means a polynomial is an expression containing more than two terms expressed as the sum of the terms of same variable of different powers. So, as we know that a polynomial is an expression that is containing more than two terms expressed as the sum of terms of same variable but of different powers, right? Let me say for an example that we have discussed earlier, that is a polynomial denoted as p of x. Let us say for example 3x plus 4, right? As it is said that this polynomial is 3x plus 4, this is a polynomial of variable x associated with 3, so that is 3x plus 4, so that is again a polynomial. Let me say another example as 3x square plus 2x plus 1. See, this is also a polynomial. See, the variables are same, x, right? But the powers, here it is x square, here it is x raised to 1 and here it is x raised to 0. So these are all the examples of polynomial, right? Now, when it comes to the powers, the term used in this chapter is the degree. So if I say that this power here, the maximum power of this polynomial here is x raised to 2, that means the degree of this polynomial is 2. Now, you will come with a question that what is the degree of a polynomial? Right? What is the degree of the polynomial? The degree of the polynomial basically means the highest power, of the variable present in the expression. Now, here we shall write this expression as the polynomial. The highest power of the variable present in the expression or polynomial is known as the degree of that polynomial. Right? The highest power of the variable present in the polynomial is known as the degree of that polynomial. Now, if I say, for example, I am having a polynomial 3x plus 7. So, how many variables are present here? If you say there are only one variable present here, then I would like to write this equation as 3x raised to 1 plus 7x raised to 0. Yes, note that 7 here you will look it as a constant term, but the constant term is written as x raised to 0, as we know that any number or any variable having a power 0 is referred to as 1. So that will be 7x raised to 0. Now see, the variables present here are x raised to 1 and x raised to 0. Now look for the highest power. whose power is highest is x raised to 1. So the degree of this polynomial is equals to 1, right? This is a degree of, sorry, this polynomial has a degree 1. Let me say for another example, 3x square plus 4x plus 5. So again, how many variables are there here? 3. Yes, good. There are 3 variables present. So that is 3x square plus 4x raised to 1 plus 5x raised to 0. Now the degree here will be equals to 2. Is it clear? So that is what the degree of a polynomial means, right? Again, let us see degree, the highest power of the variable present in the expression or polynomial is known as the degree of that polynomial. And we have already discussed the definition of the polynomials, right? Now, we are going to move further with the next thing, that is the types of polynomials. In the recent class, we have already discussed, recent class that means in 9th standard, we have already discussed about the types of polynomials. There we had 2 types of classification. The first one was classification of the polynomials based on the number of terms present, and the second one was the classification of the polynomials based on the degree of that polynomial, right? So we are not going to look at the classification of the polynomials based on the number of terms present. Let us quickly recall that. If a polynomial has only one term present in it, then that polynomial is known as a monomial. If a polynomial has 2 terms present in it, then that polynomial is known as a binomial. If a polynomial has 3 terms present in it, then that is known as a trinomial. And if a polynomial has more than 3 terms, right? If a polynomial has more than 3 terms, then that is known in the category of a polynomial, a simple polynomial, right? So that are the specific names of each and every polynomials based on the number of terms present in them. Now, in this class, we are going to study about the types of polynomials. Types of polynomials. But this types of polynomials is based on the degree of the polynomial, right? So in this class we are going to discuss about the types of polynomials based on the degree of that polynomial. So let me say that if degree of p of x, now wherever I write p of x, you will consider this as the polynomial. So if the degree of p of x is equals to 1, then that polynomial is known as a linear polynomial. Understand? A linear polynomial. When the degree of the polynomial is equal to 1, then that polynomial is known as the linear polynomial. Again, understand it. If the degree of the polynomial is 1, then the polynomial is known as a linear polynomial. Let me say, for example, if I write an example of this linear polynomial, then we have already written over here that p of x is equals to 3x plus 7. That is the best example of a linear polynomial. That it has a degree 1 here, right? Because the highest power of the variable present here is 1. So that is known as a linear polynomial. So if degree of the polynomial is 1, then that is known as a linear polynomial. Let me say for another that if degree of the polynomial is equals to 2, then that is known as a quadratic polynomial. That is known as a quadratic polynomial, right? If the degree of a polynomial is 2, then that is known as a quadratic polynomial. Let me say for example, any quadratic equation that we have studied in the earlier classes, that is 2x square plus 3x plus 1. That is an example of a quadratic polynomial, right? What is a quadratic polynomial? A polynomial having a degree 2 is known as a quadratic polynomial. What is a linear polynomial? A polynomial having a degree 1, that is known as a linear polynomial. A polynomial having a degree 2, that is known as a quadratic polynomial. Now let me discuss about the third one. So this was the first one, this was the second one, and this is the third one. That if degree of p of x is 3, then that is known as a cubic polynomial. Cubic. The highest power of the variable present here in this polynomial will be 3, right? So let me write down any example, any random example of this polynomial, that is x cube plus 2x square plus 3x plus 4. This is a random example here, right? So the degree of a polynomial is 3, then that polynomial is known as a cubic polynomial. For example, x cube plus 2x square plus 3x plus 4. So this is the classification of the polynomials based on the degree of the polynomial, right? Here we are going to discuss only about the 3 types of degrees, that is degree of polynomial of degree 1, polynomial of degree 2, and polynomial of degree 3. So polynomial of degree 1 is known as a linear polynomial. For example, 3x plus 7. A polynomial of degree 2 is known as a quadratic polynomial. For example, 2x square plus 3x plus 1. And a polynomial of degree 3 is known as a cubic polynomial. For example, x cube plus 2x square plus 3x plus 4. So that is the classification of the polynomials based on the degree of the polynomial. Is it clear? Okay. Now, once we get the degree of the polynomial, now we are going to find out the zeros of the polynomial. Yes, exactly, the zeros. Zeros, in other words, when referred to an equation, is known as the roots of the polynomial. Right, but here we are going to strictly say the zeros of the polynomial and not the roots of the polynomial. So mind it, we are going to find out the zeros of the polynomial. Right? Before finding out the zeros of the polynomial, quickly identify by yourself. I am writing down some examples here. Right? So try to find out the degree of the polynomial by yourself. You just need to write down the degrees of the polynomial. Write down the degrees of the given polynomials. Then we will discuss it here, what the answers are. 4x plus 3, see, these are some 5 examples that I have written here, right? I just need you to find out the degrees of each and every polynomial by yourself and write down. We shall discuss it here in 2 minutes, right? So write down the questions and try to find out the degree of this given polynomials. Okay, let us see for the first one. The first one is an example of a linear polynomial. So the degree of this polynomial here will be 1. Right? The degree here will be 1. Second one, if you notice that the terms here are not arranged according to the powers in ascending order. right? So in descending order. So what we are going to do is, first of all we shall arrange these terms. So arranging these terms according to the powers in descending order, I shall get x cube plus 3x square plus 2x plus 4. Good. Are you getting this? So if I get this polynomial, it would be easier for me to get the degree of the polynomial. So here the degree is equals to 3. Is it clear? Okay. Moving to the next thing, you must get the answers here. Degree is 1 here, degree is 3 here, right? Now the next thing, the next polynomial is 4x plus 1 plus x square. So again, if I say that the polynomial here given is not arranged as per the degrees in descending order, so first of all let us arrange x square plus 4x plus 1. Now you can clearly see the degree here is equals to 2, right? So this is a quadratic polynomial. Is it clear everyone? Okay. Looking for the fourth example, that is polynomial given is equals to 7. Notice friends that the polynomial given here is only a number 7, that is a constant term. And in class 9 we have discussed that a polynomial having only a constant term is known as a constant polynomial or a zero polynomial. Why it is known as a zero polynomial? Constant polynomial, it is understood that having only the constant term, it is known as a constant polynomial. But why it is a zero polynomial? Right? The answer to that is this 7 here can be written as 7x raised to 0. As I said earlier, that any number having its power as 0, any number, any variable having its power as 0 is referred to as 1. So this 7 can be written as 7 into 1, and that 1 is now referred as 7 into x raised to 0. Now see here, the degree of this variable here is 0. Right? The degree, the power of this variable here is 0. So it is known as a zero polynomial having its degree 0. It is known as a zero polynomial. It is clear everyone? This is a zero polynomial. It is not there in the syllabus, but again for our information we will keep it like it is a zero polynomial. Now looking at the fifth and last example, we are having the terms not arranged here. So first of all we shall arrange them. That is 2x raised to 5 plus x raised to 4 plus 3x cube plus 2x square plus x plus 1. Now you can clearly look at this polynomial that it has a degree of 5. Now you will get a question in your mind, sir, we didn't study a polynomial of degree 5, then what is it known as? There is no need to remember that. What a polynomial of degree 5 is known as. I am having an answer there, but we are not going to know that because it is not there right now with us. It is known, let me see again, that we know that a degree of polynomial 5 is known as a quintic polynomial. Quintic, Q-U-I-N-T-I-C, quintic polynomial. It is known as a polynomial of degree 5, but that is not related to us right now. So these are the examples of the degrees of the given polynomials. Is it clear? I hope that the answers will be matched by you and me. Okay? Now, in the next thing, we are going to move on with the degrees, the zeros of the polynomial. How to find out the zeros of the polynomial? Our next topic is the zeros of a polynomial. The zero. What do you mean by zero? Yes, you might say that Aryabhatta invented zero. That is round in shape. and it has no value before a real number, but it has a value after a real number. Good. But we don't require that 0 here. We know we want the zeros of a polynomial. Zeros of a polynomial basically means a value of the variable x. The variable x, yes. Where is the variable x present? In the polynomial. Exactly. Good. So let me write down an example here that p of x is equals to, let us say for example 4x plus 7. It is my favorite example, 4x plus 7. Okay. The zero of a polynomial is that value of the variable x at which the value of the polynomial becomes 0. So again I am repeating, that value of the variable x present in the polynomial at which that means at that value of x the polynomial becomes 0. So let me define it here that if I want to make this whole polynomial to be 0, then what should I place here in place of x? What should I put here in place of x? So if I put, let me say that I will write x equals to minus 7 by 4. Minus 7 by 4. I am going to replace the value of x by minus 7 by 4 in p of x. So what shall I get? I shall get p of minus 7 by 4. That is 4 into minus 7 by 4 plus 7. That is 4 and 4 is cancelled. Minus 7 plus 7 becomes 0. Good. So what did I get here? 0. What is 0 here? The value of the polynomial is here, 0 here. At what? At x equals to minus 7 by 4. So this value here is known as the 0 of given p of x. Now let me define it. What is the 0 of a polynomial? The 0 of a polynomial simply means the real number. See what I am writing here, real number, as we discussed in chapter number 1. What was real numbers? Real numbers is a mixture of natural numbers, whole numbers, integers, rational numbers and irrational numbers. Any of them. Any of them. Right? Here it is a rational number, minus 7 by 4, that is a rational number, right? So the real number k, let me define that real number by k. The real number k is called the 0 of p of x. The real number k is called the 0 of p of x, but when provided p of k is equals to 0. P of k is equals to 0. That means if I put that value of k in the polynomial, then I must get the answer 0. For example, that we have taken here is, let us say that our value of k is minus 7 by 4. Right? What is the value of k here? Minus 7 by 4. So if I replace this value in the given polynomial, I shall get p of k here. That is 4 into minus 7 by 4 plus 7. That gives me the total value of the polynomial as 0. So that is basically means the zeros of a polynomial. Again let me repeat it. The value of the variable x at which the polynomial or the value of the polynomial becomes 0 is known as the 0 of that polynomial. And for example, if I say that the real number k is known as the 0 of the polynomial, provided p of k must be equal to 0. Is it clear everyone? So that is what it means, the zeros of a polynomial. Is it clear everyone? Good. Now we know what the zeros are. We know what the zeros are. But do you know that this each and every polynomial defined here, the polynomials that we have studied here, the types of polynomials that we have studied here, has some geometrical representation. Geometrical representation, that means a graphical representation of the polynomials. Right? They have they have a specific criteria, they have a specific graph, they have a specific nature. Each and every polynomial has a specific nature, that how they are shown graphically. So now we are going to discuss about the geometrical representation of the zeros, or basically it means the graphical representation of the zeros. So let us quickly see what the geometrical representation or what the graphical representation of the zeros express. Right? Quickly recall what we have studied here right now till now. First of all, we studied about the definition of polynomials. Then we studied about the degree of the polynomials. Then we studied about the types of polynomials. Then we studied about the zeros of a polynomial. And now we are going to discuss about the geometrical representation of a polynomial. Let me erase this. Is it clear, everyone? Good. The geometrical representation basically means the graphical representation. Okay. I think some of you might know that how the polynomials are being represented graphically. Right? Let us make it clear how they are expressed, they are drawn graphically, and then we shall see the examples of each and every polynomials. Right? First of all, let us see the linear polynomial. A linear polynomial. What is a linear polynomial? A polynomial having a degree 1 is known as a linear polynomial. Good. We all know that. Right? Now from here on, I shall give you the brief description of each and every polynomials, and then we shall discuss about the graphs of that polynomials, and also we shall discuss how to plot them on the graph paper. Right? Sometimes it might be asked, right, what is the graph of the polynomial, how a linear polynomial is expressed graphically, what are the zeros of the polynomial, and so on. Thus all questions are asked in the examinations. Recently in the board examination it was asked that what is the graph of a quadratic polynomial. Now a quadratic polynomial is represented graphically in the form of a parabola, right, that we will discuss here right now in the next topic, that is quadratic polynomial. Before that, coming to the linear polynomial, right. So a linear polynomial has a general form. A linear polynomial has a general form of p of x equals to ax plus b. You need to remember that it has a general form of p of x equals to ax plus b. Now if you will closely look here sorry, if you closely look here at this polynomial, that somewhat seems to be like a linear equation in two variables, as we studied in standard math, right, where the second variable has its coefficient 0. Can you notice it here? Ax plus by plus c equals to 0. Yes, good. Ax plus b equals to 0. Note that the variable y has its coefficient 0. So that is not present here. So that is again a linear polynomial for us. Right. Let me write down this polynomial as y equals to ax plus b. Right, y equals to ax plus b. If I write it as p of x equals to ax plus b, or if I write it as y equals to ax plus b, both the things are correct. It is not wrong here. Right. Now, what we need to do is, I want to represent them graphically. So I need to plot the graph of this y equals to ax plus b. So how to plot? Let us take a real time example that I am having an example p of x is equals to 6x plus 7. P of x is equals to 6x plus 7. Now, in standard line we again studied the coordinate geometry. See, this all the things are linked with standard line, each and everything, right? So I will just make you recall that what you have studied. You just need to recall them and look for the further explanation, right? We have already studied how to plot the graph of any equation, any polynomial given to you. For example, p of x is equals to 6x plus 7. Let me write it as y is equals to 6x plus 7. So, if I ask you to draw the graph of this y equals to 6x plus 7, then first of all, what you are going to do? Yes, exactly. What you are going to do is, first of all, I shall find out different solutions to this polynomial, to this equation. What shall I do? I shall find out different solutions to this equation and then I shall plot them on the graph. So how to find out the solutions? First of all, let me make a table like this, x and y. We shall assume different values of x for which we get different values of y. So if in place of x I put 0, then I shall get y is equals to 7. Note that 6 into 0, that is 0, and y equals to 7. In place of x, if I shall put 1, then I shall get y equals to 13. And in place of x, if I shall put minus 1, then I shall get y equals to 1. Yes or no? Yes, good. So we got some different ordered pairs for the solution, that is 0, 7, 1, 13 and minus 1, 1. We are going to simply plot this on the graph and I shall get the graph of this linear polynomial. Let us look quickly how the graph of a linear polynomial is. That is 0, that is positive x, positive y, negative x and negative y. You need to draw the graph, so you need to go on y-axis up to 13 and you need to go on x-axis up to minus 1 and 0. So we are having 0, 1, 2, 3. On this side minus 1, minus 2, minus 2. On this side I shall have 2, 4, 6, 8, 10, 12 and 40. On the negative side I shall have minus 2, minus 4, minus 6 and so on. So let us see the graph of this. First of all, the first one is 0, 7. Right? So on 0 and you are having a 7 here. So that is this point 0, 7. Then we are having 1, 13. So that will be somewhat here 1, 13. And the other one is minus 1, 1. So it is minus 1 and 1. So that is over here minus 1, 1. If I connect this with the help of a scale, I shall get a straight line here. Right? This is our equation. This is the value. Sorry, this is the graph of the polynomial 6x plus 7. Now, looking at the graph, what can you say? It is a straight line passing to minus 1, 1, 0, 7 and 1, 13. Right? So, the given polynomial is a straight line or defines a straight line. So, what can you come to a conclusion that a linear polynomial shows a straight line. This can be asked in a 1 mark question. Right? What does a linear polynomial show? A linear polynomial shows a straight line. The nature of a linear polynomial, that will be a straight line. So before starting this topic, I said that recall that what was the nature of a linear equation in two variables was. Right? Again, you can see that a linear equation in two variables also showed a straight line. A linear polynomial here also shows a straight line. Is it clear everyone? So that was about the geometrical representation of a linear polynomial. You can look at this. Okay. Now, what we are going to do is, we are going to start with the next thing, that is the geometrical representation of a quadratic polynomial. Right? The geometrical representation of a quadratic polynomial. So let me write down here itself. For a quadratic polynomial, a quadratic polynomial has a general form of p of x is equals to a square plus bx plus c, or in other words, if I write it as y is equals to a square plus bx plus c. These are the general form of a quadratic polynomial. P of x equals to a square plus bx plus c, or y equals to a square plus bx plus c. Now, this is somewhat similar to a quadratic equation. Who knows a quadratic equation, right? But we are not going to equate it to 0. We are going to equate it to y equals to this. Let us say, for example, if I am having a real time example, that is p of x is equals to x square minus 3x minus 2. I need the graph of this. Before discussing with this equation, with this given example, let me see what the graph of a quadratic polynomial will be. A quadratic polynomial will be having a graph of a parabola. Right? The graph of a quadratic polynomial will be a parabola. Note that this was asked in the examination, in the recent board examination, that what does the graph of a quadratic polynomial show? Right? Now, with the condition given to them was, the question asked actually was, for a quadratic polynomial p of x equals to ax square plus bx plus c, provided p is greater than 0, then what will be the graph of this polynomial? Right? Let us solve this example and then look at the nature of this graph. Note that the value of a that means the coefficient of x square. What is a? The coefficient of x square. What is b? The coefficient of x. And what is c? The coefficient of the constant or the constant term itself. Here again, what was a? The coefficient of x, and b was the constant term itself. So we will discuss this. We will discuss this after solving the equation and after solving the polynomial, and let us look at the graph of this polynomial here first of all. So, if I am to find out the zeros here, right? First of all, what will be the equation here? Okay, like don't find out the zeros. We are going to directly find out the solution because we need the geometrical representation. Therefore, y equals to x square minus 3x minus 4. Right? So, finding out again the the solution x. If I take x equal to 0, then I shall get y equals to minus 4. If I take x equals to 1, so I will get 1 minus 3, that is minus 2 minus 4 minus 6. And if I take x equals to minus 2, then that will be 1 plus 3, 4 minus 4, that is 0. Is it clear everyone? Okay, so these are the zeros of this polynomial. Yes or no? Okay, not the zeros, sorry, my mistake. That is the solution of the given polynomial. Now we shall plot them on the graph. So the graph of this quadratic polynomial will be somewhat like this here. That is x, y, negative x, negative y. This is our position. So on the x-axis we need 0, 1, minus 2, and on the y-axis we need 0, minus 4, minus 6. So that is 1, 2, 3, minus 1, minus 2, minus 2, minus 1, let me get minus 2, minus 2, minus 6, minus 2, minus 6, minus 2, 6. Okay, on 0 I am having minus 4, so that will be 0, minus 4 here. So we got the order points 0, minus 4, 1, minus 6 and minus 1. Okay. On 1 I am having minus 6, so that is 1, minus 6 somewhere here. Right, that is 1, minus 6. And on minus 1 I am having 0, so on minus 1 it will be 0 here. Like this, right? So if I plot the points and if I connect them, then I shall get an equation like this. It would be on the other side also, right? So the graph here is somewhat in the shape of an U-shaped graph, and U-shaped graph in the mathematical terms is known as a parabolic curve, a parabolic graph, right? So now you can see here this U-shaped graph that is plot here, that is shown here, has its mouth opening towards the upper side, towards the y-axis, right? And this parabola when defined to an equation y equals to minus x square plus 3x plus 4 will show the reverse case. That means this parabola will have its mouth opening towards the downwards. So what does the conclusion here is that when referred to the general equation y equals to ax square plus bx plus c gives you two cases provided a is greater than 0 and a is less than 0. What does a mean? A means the coefficient of x square there, right? A means the coefficient of x square there. So if the coefficient of x square is positive and if the coefficient of x square is negative. If the coefficient of x square is positive here, then the graph is a parabola opening upwards, right? And if it is less than 0, then the graph is a parabola opening downwards, right? This is what this both bifurcations mean. Bifurcations, that means based on the coefficient of x square, right? That means if the coefficient of x square is greater than 0, then that would be a parabola opening upwards, and if it is less than 0, then that would be the parabola opening downwards. This was the question. So we were discussing about the question that is asked here in the examination was the nature of the parabola, the nature of the graph of a quadratic polynomial, right? So again we shall discuss here that if a is greater than 0, then the graph is a parabola opening upwards, and if it is less than 0, then the graph is a parabola opening downwards. This was the question that was asked in the recent board examination, right? So you must look at this again. It might be that in the next examination they might ask about the linear polynomial, or they might also ask about the cubic polynomial. So you must know the nature of the graphs, what each and every polynomial has, the nature of the graphs, what does they show, what does they represent, how to plot them on the graphs, and so on. You must know this all things. So it would be better if you clearly look at this, and if you are having any doubt, then we will clear it right now. Okay, got it, friends? Let us move further with the third kind of the polynomial, that is a cubic polynomial. Right? So what is a cubic polynomial? A polynomial having a degree 3, that is known as a cubic polynomial. So let me write down here. Cubic polynomial. A polynomial having a degree 3 is known as a cubic polynomial. So the general form of a cubic polynomial is written as p of x equals to ax cube plus bx plus c. Sorry, ax cube plus bx square plus cx plus d is equals to p of x. Right? So that is the general form of a cubic polynomial. Or you can also write it like y equals to ax cube plus bx square plus cx plus d. Right? So that is also a cubic polynomial. Okay. Now, the graph of this, the representation, the geometrical representation of this polynomial is a waveform. Waveform. Have you seen waves in the ocean? The waveforms, right? It shows somewhat like that. So let me write down an example here that p of x equals to x cube minus 4x. Note that I have taken a very simple example. I have not taken somewhat a complicated example which has all the variables present here. So it would be tedious for us to draw the graph of that. Right? So I have taken a very simple example that p of x is equals to x cube minus 4x. Or let me write down as y equals to x cube minus 4x. So let us find out the solution first. I shall take different values of x and I shall get different values of y. So if I take x equals to minus 2, so that would be minus 2 cube minus 8 plus 8, that would be 0. If I take x equals to minus 1, so I'll get minus 1 cube, that is minus 1, minus 4 minus 1, that is minus 4, minus 1 plus 4, and that would be 3. Right? If I take x equal to 0 here, I shall get 0. If I take x equal to 1 here, what shall I get? 1 cube, that is 1, minus 4 into 1, that is 1 minus 4, and that is minus 3. right? And if I take x equal to 2 here, that is 2 cube, 8 minus 4 into 2, 8, that is again 0. So I got some 4 or 5. These are the 5 different solutions of this given polynomial. Now what shall we do is, we shall simply plot them on the graph. We shall simply plot them on the graph. And the graph of this polynomial, we shall see the nature of the graph of this polynomial, right? So try to plot it by yourself, start doing this, and let us verify that we are getting the same results or not. So first of all, what we shall do? We shall draw the x-axis and y-axis. That is 0. On the x-axis we need 1, 2, minus 1, minus 2. So that is 1, 2, 3. On the y-axis we need minus 1, minus 2, minus 3. On y we are having 1, 2, 3. Minus 1, minus 2 and minus 3. Right. So the ordered pairs that we get here is minus 2, 0, minus 1, 3, 0, 0, 1, 3 and 2, 0. Right. So let us plot down them. Minus 2, 0. So we will get it here. Minus 2, 0. Then we are having minus 1, 3. That is somewhere here. 0, 0 is the origin itself. Then we are having 1, 3. Right? Sorry, my mistake. 1, minus 3. So that would be somewhere here. And that is 2, 0. So that would be somewhere. So if I join them, don't join them with the help of a scale. I'll get a graph of this polynomial somewhat like this. You can see that the graph is in the shape of a waveform, right? So the graph of this cubic polynomial that is being expressed here is the waveform, right? The graph of a cubic polynomial is a waveform. Again, let us recall, the graph of a linear polynomial was a straight line. The graph of a quadratic polynomial is a parabola. Again, we have defined them in the two different manners, that if the coefficient of x square is greater than 0, then it would be a parabola opening upwards, and if it is less than 0, then that would be a parabola opening downwards. And lastly, the graph of a cubic polynomial that is in the shape of a waveform, right? So these are the geometrical or graphical representation of all the three polynomials: the linear polynomial, quadratic polynomial and cubic polynomial. Get a look over it. So friends, today let us recall that what we studied today is the basic definition of polynomial. Then we have discussed about the degree of the polynomial. Then we have discussed about the zeros of the polynomial. And lastly we discussed about the geometrical representation of polynomials. So we shall keep here today till this much. Recall it by yourself, get a look over it, and we shall continue with the relationship of the zeros and the coefficients in the next lecture. Thank you.